So in the C 15.4, we are doing the glass part. In the glass is mainly silica, SiO2, and it contains other raw materials such as lime, C calcium carbonate, and sodium carbonate, right? Fine. Now, you to see that the common form of glass, there are two types of glasses. One is soda lime glass, and one is a borosilicate glass. You can write down over here one, two, right? There are two kinds of glasses, right? Now, if you see that glasses are recycled, right? Have you seen in the UK what happens? There's a separate bin for the all the glass bottles. Have you seen that? Right? When you dispose of the bin, the third small bin is for the bottles of the glasses, right? So over here, what we do? We are taking what? We are taking the example of the soda lime glass. In the soda lime glass, what we take? We take SiO2. And what is lime? Soda. What is soda? Soda is sodium carbonate, right? Isn't it? Fine. This is soda. Soda lime. As the name says, soda lime. What is lime? Lime is calcium carbonate, right? We take SiO2, that's the main component of the glass. Soda is Na2CO3, lime is CaCO3. Then what we do? Then we heat it, right? At around 1500 degrees centigrade, right? Now at this high temperatures, what happens? All these will be melting, right? And they'll be mixing. After heating, we cool down the glass. When we cool down this mixture, the glass turns into solid, right? Now this is very important and crucial, right? Isn't it? This is a very important portion. You were shocked to hear this. The particles, they do not form a regular pattern. Can you see this? Understood? They do not form a regular lattice structure, right? Isn't it? Fine. That's the thing you have to know, right? Now it is something like the particles are frozen in one place. This is called as what? Soda lime glass. What is soda? Sodium carbonate. Sodium carbonate. Lime is calcium carbonate, right? Now, we know that there are two kinds of glasses, soda lime glass and borosilicate glass. Soda lime glass, you cannot put in the micro ovens, right? Or in your heaters, right? Micro ovens you cannot, right? Is it? Fine. Suppose when we make paneer, right? Paneer roast, we have to use borosilicate glass, right? Which can withstand our temperature in the microwave, right? Clear? Or during baking, we use a borosilicate glass. What is borosilicate glass? In the borosilicate glass, we are using what? Boro. See, the name suggests boron trioxide. And we take silica, and this we heat it, and after that, at a 1500 degree, it melts, and we cool it down. And it will be in a unregular pattern each side. This borosilicate glass is very useful for what? Very useful to use in higher temperature, right? Understood? Now come to the part of the ceramics, right? If you see ceramics, what are ceramics? In the ceramics, we are seeing that there are many ceramics we use, right? How the ceramics is made? They are made by molding the wet clay. In the right, we take the wet clay. Clay contains what? Clay, if you see, clay contains different metals, right? Such as aluminum, metal ions, potassium, non-metals also, silicon, oxygen, with ionic bonding between the ions, right? Now, what happens when the clay is wet? What happens? Water will be there in between the layers, right? Isn't it? Isn't it? Water will be there in between the layers, right? Wet clay. It's slimy. Now, when you take the clay and take the shape of a pot, right? After that, what we do? We heat it in a furnace or at around 1000 degrees centigrade, right? When you heat it at 1000 degrees centigrade, what happens? The water in between the layers, the water of the layers in between the layers, right? They are driven out. Understood? And what happens? Ionic bonds form, right? In between the layers, right? Clear? And thus you form a gigantic structure, right? So thus you'll be having a very sturdy kind of thing, right? Thus it makes what? This makes particular ceramic harder, right? But what the disadvantage of the ceramics, you can tell me? Have you ever dropped a cup from your hand? Have you ever dropped a cup from your hand? It breaks. So ceramics has got a negative point. What's the negative point? Ceramics are extremely brittle, right? A sharp blow can distort the layers, right? And thus we are seeing that this is a very important portion we have to learn, right? Clear this part? So that was all about the glass and the ceramics part, right? Now come to the part of the composites. What are composites? If you see composites, composites will be what composites are one material embedded into the another material, right? That is called as composite. Your the the one material embedded in another material. There are two substances we have to do. First is known as matrix. Second is the fibers or the fragments, right? Fibers or fragments are inserted into the matrix. Is it clear? Composite contains two particular substances. Fibers or fragments, number one. Number two is the matrix. This matrix acts for the binder. Now see fiberglass. What is fiberglass? As the name suggests, glass fibers are embedded in glass fibers are the fibers embedded in a polymer matrix, right? Clear? The polymer matrix is got a low density, but it's very strong like glass, right? Where it is used? Boats, skis, surfboards. Now concrete, what is concrete? We take the matrix as a cement, and the fibers or the fragments are what? The sand and the gravel, right? And this is very strong. What is wood? Wood is a natural composite made by God. A organic polymer matrix is there. There's a matrix, organic polymer matrix. Inside it, what happens? We have got cellulose fibers, right? Inside it, right? Now come to the part of carbon fiber. What is carbon fiber? Carbon fiber are what? We take carbon nanotubes. Carbon nanotubes we take, and we put it in what? We put it over a polymer matrix, right? Carbon fibers. See, glass fibers are what? We take glass fibers in polymer matrix. Ski boats we make. Carbon fiber composites are what? We take carbon fibers, carbon nanotubes, and we put it in the polymer matrix, right? This is very light yet strong, right? Where it is used? Aerospace, sports car manufacturing, right? So this was all about the C14 portion, right? Thank you so much.